This is chapter 6, problem number 28. The magic number, the lucky number for this problem is 6. If it requires 6 joules of work to stretch a particular spring by 2 cm from its equilibrium length, how much more work will it require to stretch it an additional 4 cm? Okay, few words here. Equilibrium strength, length. Equilibrium means when the spring is relaxed. There's no force acting on it. Okay. So I'm going to write down a few formulas for the spring. The force need to stretch it is equal to, or compress it, spring constant times delta x. That's one formula. The second formula is the potential energy of a spring is equal to half times spring constant times delta x squared. All right, so it requires 6 joules to move, to stretch this one, okay? So based on these conditions given, can we figure out what the spring constant K is? So the energy, I'm going to plug in here, energy is equal to 6 joules, is equal to half times K times delta x squared. What is delta x? 2 cm. But can we use the unit cm? No, we need to use the standard unit, the SI unit. So it will be equal to 0.02. 0.02 meter per square. All right, so now based on this one, can we calculate for the K? Yes. So we multiply by on both sides. So 3, then divided by point. Oh, I make a mistake here, I think. So 2 is 12. You multiply by 2 on both sides. Divided by 0.02 squared, that would be equal to K. That would be equal to, so 12 divided by 0.02 squared. I get 30,000. 30,000 spring constant. 2 ways you can write it. Okay, it can be meter. Okay. How much more work will require to stretch additional 4 cm? Okay, so let's see what the total elongation. Total elongation delta x now is equal to, we first stretch it with 2 cm and then another 4 cm. So it will be 6 cm or 0.06 meter. Okay. So what is the total energy? Okay, so energy, potential energy is equal to half times K times delta x squared. So it's equal to half times, we already find out what K is. So times 30,000 times 0.06 squared. That will be equal to, so I have 0.06 squared times half times 30,000. Okay, so what I see here is 54. Okay, so when you stretch the first 2 cm, you need 6 joules. You stretch another 4 cm. Do you think you just add another 6 here, at 12? No. Over here, you get 48 joule in order to stretch it further in this direction. You add up to be equal to 54. The lucky number for this problem is 6.